Most students try to memorize this, but I'm going to help you understand it instead today on High Peak Education. What is a one-to-one function? Think of the negative as going south, not north. The reason this is all important is because there are analogies to trig functions. Suppose my function f of x is x cubed. There's a reason I chose x cubed. X cubed is a certain kind of function that has really nice properties. Not only is f of x a function, but it's a very special kind of function. One-to-one function. What is a one-to-one function? All functions, for each input x, there is only one y. That means they pass the vertical line test. Each vertical line is an x value so that the output y is single valued. But one-to-one functions also pass the horizontal line test. This means that we do not have multiple inputs giving us the same output. In other words, for each x, there is one and only one y value output. The point is, not all functions, in fact many, are not one-to-one. But a good analogy of functions is inputs to computers. Like if I print a document, that is not one-to-one because multiple inputs give me the same output. I can go file print, I can do Control P, or I could do something else fancy. Suppose I want the output that I want to type the letter K. There's only one button I should press, and that's the K button. But what that means is, typically when you're typing words, those are one-to-one, which means there's only one input and there's only one output. There's a perfect correspondence. Only one-to-one function can truly have it so that we have an inverse. So that's why I chose x cubed here, because x cubed is one-to-one. You know, if you look at the S curve, it passes both the horizontal and vertical line test. So think of the negative as going south, not north. Think of the reciprocal as kind of going upside down. So it's sort of smaller, not bigger. And I want you to think of the inverse function as the undo of a function. Now let's think about why this is the case. The negative has this special property. When you add a function to its negative, you get 0. So I'd get that lovely number 0. So you can add two functions and get 0. Suppose f of x equals x cubed represents driving from Denver to Fort Collins. Let's suppose it's 3 in the morning and nobody's on I-25 and the positive x-axis is oriented towards Fort Collins. If there's no cars around, if f of x is driving towards Fort Collins, north, positive x, then the negative is just driving from Fort Collins to Denver. Just the opposite. See how that works? The reciprocal is going to be different because is not the reciprocal going to be 1 over x cubed? Now, that's not the same thing as negative x cubed. So the reciprocal is going to be 1 over x cubed, but we could write that with a negative exponent, x raised to the minus 3 power. It's kind of like upside down, and it's getting smaller, not bigger. Suppose the car was driving towards Fort Collins, but it was driving upside down, and because the roof kind of scrapes against the pavement, the car is not going faster, it's going slower. Like the more, it's still going positive, but it's getting slower. Does that make sense? Suppose I do f of x and not add, but suppose I do times h of x. We don't get 0, we get what special number? Yeah, 1, because something times its reciprocal is 1. Last thing, the inverse function. The inverse function is like saying this. Instead of 1 over x cubed or negative x cubed, it's the cube root of x. That sounds different, but it also means something different. That's why it's the inverse function. By the way, cube root of x is the same thing as 1/3 for the exponent because it's the first power and the third root. Now, I want you to think of the inverse function as like undo. So if I type the letter K, I could be like, oh, I accidentally didn't mean to type that. I could do Control Z. Maybe a better analogy is you drive out your driveway, you realize you forgot your lunch, and you reverse it back into your parking spot. So going forward, then going backwards, you have done nothing because the forward function and the inverse function get you back to start. Now, an inverse has this special property. So if I go f of k of x, that's like taking that square root function and cubing it because I apply the cube to the cube root. When you do that, you get back x because you just like where you started. Do you see that people can get these jumbled in their mind? But they all mean something different. Opposite is like Don't go north, go south. Reciprocal is like go upside down and slow it down. Inverse is like undo, like go in reverse. Hey, thanks for checking out High Peak Education today. Would you do us a favor and like, subscribe, comment, and share this video? It really helps us to grow the channel, extend our reach, and it helps us to make more content like this to help you even more. Thanks for your support. Hope you're enjoying it. Let's get back to the video. The reason this is all important is because there are analogies to trig functions. Suppose f of x is sine x instead. Any guesses on what the negative is? Yeah, sure, just negative sine x, right? That would just be an x-axis reflection. And remember, it has the same properties in that you can add them together, get 0. What would the reciprocal of sine x be?
Cosecant.
Cosecant x. Does that make sense? In trig, we define all of the reciprocal functions of the three main trigonometric functions. One of which is cosecant x, which is the flip of sine, then secant x, which is the flip of cosine, and then cotangent x, which is the flip of tangent. So what would the inverse be?
Is that the sine to the negative 1x?
Yes, that's the inverse of sine, sometimes called the arcsine. If you take sine of inverse sine, you should get x. And if you take arcsine of sine, you should get x. Another way to think about this is with trig functions, the input is theta, like an angle, and then the output is like a ratio or like a decimal. With an inverse trig function though, the input is a decimal or a ratio, and the output is an angle. Even though inverse sine is a lot more commonly written, it's a little more common in computers and calculators and so on. Arcsine, in my opinion, is a little more instructive because arcsine says basically this: give me an arc, which means give me an angle, whose sine is this ratio. Notice the input is a ratio. So it's like, give me that angle. So if you understand this table, you really do understand like the differences, and then the rest is going to be more or less detailed.